Hi everyone, let's continue building a dungeon crawler. So let's see what we have so far. So we can run around in our world. Grid-based, 90-degree turns. Pretty old school. Cool. And we're also a ghost because we can just move through walls. And that will be today's main objective. Making sure that we respect walls. So let's get started. So let's think about this for a minute. So what I am envisioning is in our player movement, we should make sure that we can player movement should not move through walls. So we will need some form of a map. And that map let's say we define it as a set of characters, so something like this. This will be a start position. Could use, let's make an S for start. And let's give it a bit of room to walk around. And let's say that if we don't need this S here, so let's create a player. This player will be at 0, 1. It's called position. And the heading can be just north. Then let's say we move our player forward, and then we expect player's position to be still the start position, so we'll still be in this position. To get this to compile, we need a map. So another folder. I need an empty file. I'll quickly create an initializer that takes an array of characters. So at least our code should now compile. Oh. These are not yet characters. They should be characters now, so let's see if this now compiles. Okay, so obviously this test fails. Of course, we will need to use our map somewhere. So let's assume that our move command also has a map. This means that now a couple of other positions no longer compile. So we'll need a map. We'll need to pass in empty map. We'll need to have a big empty map to use in all these tests. So this will be a map that's just made out of what's the biggest one? Maybe it should be 100 by 100. Let's assume a map is just floor unless it has walls in it. So let's simplify this a bit for now. So let's say our map has a default value, and now we can just create empty maps. So now we should be able to, did I miss one still? Oh, in the game itself, I believe. Okay, we will need to have a map here as well. So for now, let's just let's just assume that our world has a map. So we can say in world.map. Let's see if this is all of them. So now we at least have a compiling thing again, and there's just still that one test that doesn't work because we're not taking the map into account. So we will need to initialize the map somewhat. So let's say that our map keeps track of a private variable called walls, and this will be just a set of coordinates. So we only, for now, we only take walls into account. And then we go from for row in 0 map array.count, for column in 0 map array.count, and then we say that if map array row column equals a hash sign, then we insert a coordinate, column and row. And this doesn't work yet because a coordinate doesn't conform to hashable, but that's easily fixed. Okay, so now we can put coordinates, walls into coordinates, and now in our player we should be able to say let new position is our position plus this direction, and if map, oh, we need to inspect the wall somehow. We'll create a simple function called hasWall at coordinate. If map has wall at new position, well, if then we don't do anything. else we return, else we say our position will be the new position. Let's see if this at least, can't I add these together? Let's look into our coordinates. This one requires then also a +1. So that will be a coordinate that has and the left hand side dot y plus a right hand side dot y, and then this one could just be left hand side is left hand side plus right hand side. Let's see if this still works. Okay, so now our test passed now, so we should not be able to move through walls anymore. Let's see if we can clean up some of this code somewhere. We'll revisit this initialize at a later time, so I'll make a quick note of that and detect that. Let's see what else. This one is still fine, I guess. Our player. Maybe we should just say guard map has wall at new position is false. Else we return. This should still pass. Okay. Let's make sure we commit these changes. So we create a new test for not moving through walls. No, we don't have to push yet. So if you map, we have player, this is all fine. I'm actually going to reuse this map because I also want to have this map show in our game. So let's go to our content view. I don't need the canvas, and we have our world. Let's just say we have this map for the world, and in our game view we somewhere create FAQ positions. What we could do is, how can I quickly get these positions from the world? Let's think of this. The map doesn't have a size yet, although it could have. We could say it has a minimum X value. And that will be our, let's see, our rules.map, and we only need the X value, and then the minimum value, or 0. We could do something similar for Y. A max X and a max Y. So these will now be max values. And we could go to our game view, and instead of all these positions, we could say we go for row in row.map.min x to world.map.maxx, and then the same for columns. And these should be including ranges. If the world has a wall at the coordinates column and row, then we create a cube. And this world position is a sim3, and the cube position is, I think, is a coordinate. So we need again to convert a coordinate to a position. Let's see, what does the world position take as a function? Yeah, sim3 float. So we could use our cube +2 sim D, because I think we already created something for this. And this is our coordinates. And now we should be able to get rid of this one. And now we should have our world as it's defined. And we need to make sure that our player is now at the right position. So it has the right start position. So we might need to inject that one, but let's see if... Let's see what happens. So let's run. We'll probably start in a wall somewhere. So we're now looking around all our things, and probably we can't move through the walls, but of course I want to be in our map, not outside of it. So we somehow need to set the start position correctly. So we have this world. For now, let's just hard code the start position to be 1.1 should be fine. So now we should be inside these two places. So yeah, we have this very small room that we can walk around in, but we can no longer move through walls. Maybe we should make a slightly more interesting room. So let's make this one a little bigger. Let's see what this looks like. Okay, so we have now some sort of alcove, and we can indeed run around, but we cannot get out of the room. So for now, I think this should be good enough. Let's see if there's anything in terms of code we can clean up in the last 10 minutes or so. So let's check our tech depth. So we have a compass direction that has both, it has both that function rotated clockwise and the rotated clockwise computed variable. I think I've decided what I want to do. So let's go to our direction. Oh, it's called movement. Oh, this file should actually be renamed to just direction because it has both directions in it. So it's about this one and this one. So perhaps we can change this into, well, first we could just say could just inline this one, but instead we switch on the rotation direction. Is this not allowed? Okay, so we can't, a switch is not an option here. What we then can do is we can use a lookup table that maps from, that moves from one compass direction to another. So we move from north to east, east to south, south to west, and west to north. And here we could do something like this. Let's see if this has our test still passing. Okay. So now we can get rid of the rotated clockwise variable. Now we have failing tests because we need to make this a function, need to call the function instead of the variable. And we have our rotated clockwise. Oh, but it should default to doing this at least once. Okay. So this again passes. We have also this rotated counterclockwise, but I think I want to do the same thing for rotated counterclockwise as for the rotated clockwise one. So again, I want to create a function, because it feels really weird that this is has a different name. The only thing is that it has different so we should be able to do something like this. Okay, these pass. We can actually use this one now. We could say this is just calling this function. This should still all pass. And now we know that these are equivalent. So just the name isn't correct because these are counter. These are, my God, it's difficult to type. Rotated counter clockwise directions. Okay. This means that we here again need to call the function instead of the variable. This will pass, and this means that this to do is now done. We and rotated counterclockwise. Okay. Let's see, I don't think we have much more time. There is one thing in terms of the game view that I don't really, well, there's two things. So first off, we're hard-coded starting position for player in world. That's of course not a good thing. And also in the game view, the setup view is having a lot of it has a lot of message chains by all the additional dots. So we're looking into the world, then into a map, and then we get a property out of it. And something similar is happening in the content view. We're going to the world, we find the player, we move the player, etc, etc. And this one needs to be cleaned up. So what we can do is there's feature env in content view and game view, where the world internal variables properties get accessed directly. So it's probably feature env and or message chains. And this needs to be improved further on to keep this code base maintainable. Okay, that's enough for now. Thanks for watching and have a great day.